Okay, so let's practice by doing an example. So here we have a function f of x is equal to x minus 4 divided by x squared minus x minus 2, and they want us to sketch this function. So before starting, here's the algorithm for curve sketching. So the step-by-step process to get the information necessary that we need in order to draw this function. So the first thing that you want to do is determine the domain of f of x. Now, if you're working with a rational function, then you find the restrictions of that function, and that becomes your domain plus the restrictions. If there's no restrictions, then the domain is x element of real numbers. The next thing you have to do is find the intercepts of f of x. So the y-intercept, the zeros of your function. So that's the next step to do. Then the third thing to do is to find the asymptotes. So you have your horizontal asymptotes and vertical asymptotes, which we covered on how to determine them. And then the fourth thing you want to do is determine the critical points of f of x. So when f prime of x does not exist or when it's equal to 0. From that, you're going to determine the intervals of increase and decrease given by the sign of f prime of x. And then you'll be able to determine the local and maximums, minimums and maximums using the first or second derivative test. And then the last thing that you want to do is determine the concavity and points of inflection, which is given by the sign of f double prime of x. So to find the intervals of increase and decrease, they're given by the sign of f prime of x, so your first derivative. And then to determine whether it's towards the top or the bottom, well, that's given by the sign of your second derivative. So here's our example. So the first thing that we want to do is determine whether or not what the domain of our function is. And we notice that this is a rational function. Therefore, there will be restrictions. So to find these restrictions, what we have to do is just take the bottom and say that it's equal to 0. So we have x squared minus x minus 2 is equal to 0. This is a second degree function, which can be written as, so SPF, we have a sum of minus 1, product of minus 2. So our factors are negative 2 and 1. So this can be written as x minus 2 times x plus 1 is equal to 0. Therefore, our restrictions are x cannot be equal to 2 and x cannot be equal to negative 1. Because if we plug those values into our equation, well then we're going to have something divided by 0, which does not exist. So our domain is x element of real numbers, x cannot equal to 2, and x cannot equal to negative 1. Well, we also found our vertical asymptotes, so we know that our vertical asymptotes are equal to x is equal to 2 and x is equal to negative 1. So that's it. And then the next thing to do is to find our intercepts. So our y-intercept is equal to, so when is, so here we have y is equal to 0. So let's see to find when our function hits the x-axis. So if we have y is equal to 0, that's x minus 4 divided by x squared minus x minus 2. Well, if we multiply both sides by this, well, it's just going to give us 0. So that'll cancel each other out so that we have 0 is equal to x minus 4. So we have x is equal to 4. So that's our x-intercept. So that means when we're looking at our function now at x is equal to 4, we know that our function will cross this axis. We don't know if it's going this way or this way. We haven't determined that yet. But we know that at x is equal to 4, we have x is equal to 0, or y is equal to 0. So if we want to put our vertical asymptotes as well, what we have at 2, we'll have something like this, and at -1. And then we have our x-intercept there. So now to find our y-intercept, well, we try to find f of 0. So x minus 4, x squared minus x minus 2. So we replace f of 0. So 0 minus 4 divided by 0 minus 0 minus 2, which gives us -4 over -2, which is equal to 2. So we know that our y-intercept is at 2. So that's our y-intercept. So see, so far, based off of the domain, vertical asymptote, and our intercepts, we've determined already some points that we need. So we have our intercepts, we have our y-intercept, we have our asymptotes. So now checking. So now we need to find our horizontal asymptote. So how do we find the horizontal asymptote? Well, we write out f of x is equal to x minus 4 divided by x squared minus x minus 2. And we're going to divide each term by the highest degree of x that we have. So in this case here, the highest degree that we have is x squared. So we're going to divide each term by x squared. So we have x divided by x squared minus 4 divided by x squared divided by x squared minus x divided by x squared minus 2 divided by x squared. We'll simplify where we can, so this becomes 1 over x. So we have 1 over x minus, we can't really simplify that, so it's 4 over x squared divided by, well, this will simplify to 1. And then we have 1 over x minus 2 over x squared. Next we have to do is we plug in a large number, so we'll say x is equal to 100,000. So that'll give us 1 over 100,000 minus 4 over 100,000 squared divided by 1 minus 1 over 100,000 minus 2 over 100,000 squared. And what you'll realize is that this will give us something very close to 0. This will give us something very close to 0. This will give us something close to 0. And this will give us something close to 0. Therefore, we have something that's 0 over 1, which is equal to 0. So our horizontal asymptote is that y is equal to 0. So what that means is we'll have our horizontal asymptote here as y is equal to 0. So now that we found our horizontal asymptote and our vertical asymptotes, which we knew vertical asymptotes are equal to -2 and, or +2 and -1. And so now we can go to find our critical points. In order to find our critical points, we must find the f prime of x and our f double prime of x. So let's start off by finding our f prime of x. So we have f of x is equal to x minus 4 over x squared minus x minus 2. To derive this, we must use the quotient rule. So we know that f prime of x is equal to g prime of x times h of x minus g of x times h prime of x divided by h of x squared. So here I have g of x is equal to x minus 4. G prime of x is equal to 1. H of x is equal to x squared minus x minus 2. H prime of x is equal to 2x minus 1. So now that I have that, I can plug it into my formula. So I have 1 times squared minus x minus 2 minus x minus 4 times 2x minus 1 divided by x squared minus x minus 2 squared. So we have x squared minus x minus 2, and then we have minus 2x squared minus x minus 8x plus 4 divided by x squared minus x minus 2 squared. So then that gives us x squared minus x minus 2, and then I'm going to distribute. So this will give us minus 9x plus 4. So I'm going to distribute the negative. So it'll give us minus 2x squared. Minus times minus gives us positive 9x, and minus times positive minus 4 divided by x squared minus x minus 2 squared. That'll give us minus x squared plus 8x minus 6 divided by x squared minus x minus 2 squared. That's our f prime of x. Okay, so now that we have our first derivative, we can find our critical points. So we know that the first derivative of any function will give us our maximums and minimums. And we know that it's whenever f prime is equal to 0. So when is f prime equal to 0? Well, it's equal to 0 when the numerator is equal to 0. So we can actually simplify this complicated looking function derivative and just solve it for the numerator is equal to 0. So we have 0 is equal to minus x squared plus 8x minus 6. And we just have a simple second degree function that we can rewrite as minus x squared minus 8x plus 6. And we could take a look and see what this can be broken down to. So I believe we can simplify this SPF. So sum is negative 8, product is plus 6. The factors that I'm thinking of would work if it was the opposite. So 4 plus 2 gives us 6. So therefore, this isn't really solvable using SPF. We will have to use the quadratic formula. So using quadratics, we have A, B, and C. We have minus B plus minus square root of B squared minus 4AC divided by 2A will give us our x's. So we have minus 8 plus minus square root of negative 8 squared minus 4 times 1 times 6 divided by 2 times 1. So we have 8 plus minus square root of 64 minus 24 divided by 2. plus minus square root of 40 divided by 2. So that could be written as 8 plus minus 2 square root of 10. So because we can rewrite this as 4 times 10, which is also square root of 4 times square root of 10. Therefore, we have square root of divided by 2, which then gives us 4 plus minus square root of 10 as our x's. So x1 will be equal to 4 plus 3.2, and x2 will be equal to 4 minus 3.2. So this is equal to 7.2, and this is equal to 0.8. So these 2 points now become our critical points. So we know at these 2 points, when x is equal to 0.8 and when x is equal to 7.2, we will have a local maximum or minimum.